Hello everybody, I'm going to attempt to create a pretty short tutorial, I'm hoping 5 minutes or less, on how to complete this activity, determine the rate of ocean floor spreading. So what you see here is some data that geologists have found from the ocean floor. What they've done is they've taken sampling, they've dated the age of the rocks on the ocean surface, and these are the numbers they got. So we've learned in class that at the Mid-Atlantic Ridge, and that line is right here, it's actually 0 years old. The new rock is being created. And we've learned that if you go out on both sides, so if I go this way and I go this way from the Mid-Atlantic Ridge is right here, the age of the rocks gradually gets older and older and older. And it's almost a mirror image where you see here you got 9 million and 9 million. You got 38 and 38. So it's not exact, but it does mirror itself, in fact, in the sense that the numbers are found on both sides. So what we're going to do today is we're actually going to determine how fast the plate is moving on the Mid-Atlantic Ridge. So to do that, read the background information. Read this right here, determine the rate at which sections of the ocean floor are moving. That's what our learning target is. We're going to learn how to do that, and to do that, we need to follow the directions. So the first direction says, using a scale 1 millimeter equals 65 kilometers, determine the distance in kilometers between a Mid-Atlantic Ridge and the 9 million year line. So originally, we, meaning Mr. Phillips and I, we've already done the measuring for you. So you do not have to use a ruler. These are all the measurements. And we did that to ensure that everything's accurate, that everything's the same. So you're getting the same exact measurements as your neighbor. So the directions again are to use the scale 1 millimeter equals 65 kilometers, determine the distance in kilometers between the Mid-Atlantic Ridge and the 9 million year line. So here's the Mid-Atlantic Ridge, here's the 9 million year line. So what we have to do is just simply multiply this by 65. And 2 times 65 is 130. So to get this number, this number, this number, all that you're doing is taking this number, for example, 5, multiply it by 65 to get this number. To get, find this number here, just take 4 times 65. To get this one here, take 2 times 65. All right, so now we got 130. Let's go to the second set of procedures. Convert each distance from kilometers to centimeters. Now, the reason we're going to do that is because we know the ocean floor plate, it moves very, very slowly, about as fast as your fingernails grow. So measuring it in kilometers per year, how far it's moving, it'd be a really, really small number where it'd be like a decimal 00. So we're going to switch it over to centimeters, so we'll get a number that's a little bit more, I don't want to say it's more accurate, but it's easier to contemplate in your mind. It's easier to understand. So to do this, we already found the kilometers, and now what we're going to do is we're going to convert those kilometers into centimeters. And we do that by multiplying by 100,000. So on the next set of procedures, I have 130. I'm simply going to multiply it by 100,000. So 65, actually not 130, but take 65, you times it by 2 to get 130. Now take 130, multiply it by 100,000. So it is 130 times 100,000. Now, the shorthand way of doing that is write 130, add the 5 zeros, because you're multiplying it by 100,000. So when I get this number here, 5 times 65, multiply it by 100,000 by adding 5 zeros. So all we did was I added 5 zeros to the 130. All right. Now, to get the last thing, we have to look at the directions here. All we're doing is calculating the approximate age difference between the lines. Now, to do that, all I have to do is take 9 minus 0. Put a 9. But this is key right here. Remember, the ages are in millions of years. So I'm going to write my 9 down, but then I'm going to make it 9 million. So if I do this next line over here, I take 38 minus 9. And 38, again, you can use your calculator. 38 minus 9 equals 29. And I'm going to make it millions of years. So I'm going to add my 6 zeros. So that's the shorthand way of doing it. So now we're to the last set of procedures, number 4 right here. Make sure I can see everything here. So here's the equation it used. Rate of ocean floor motion. That's what we're going to find down here. So now we're going to start to see how fast it was moving. We're going to learn that it actually moved at different speeds throughout time. and we're ultimately going to find the average distance. To do that, you use this equation here. The actual distance the ocean floor moved in centimeters, which is this number right here, and we're simply going to divide that by the age right there. So here's our example. Take 13 million, and you're going to divide it by 9 million. So plug that into your calculator. 13 million divided by 9 million, and you should get 1.4, so I'm going to write 1.4 here. Now, we always want to round to the nearest tenth. That way, all of our numbers are going to be accurate. Now, if you have a calculator similar to this at home, sometimes it's hard to get such large numbers in here. So again, another shortcut is to take the common zeros and cross them out. And now if I take 130 divided by 90, and I can do that, 130 divided by 90, I get 1.44. I round to the nearest tenth. That's how I come up with 1.4. So once you do all these numbers here, remember, round to the nearest tenth, you're going to add them all up, and you added 1, 2, 3, 4, 5, 6, 7 numbers, so add them all up and divide by 7 to get the average. And ultimately, this is the number I'm going to look at to see if you did the assignment correctly, because if this number is exactly the same as the answer key, I know everything else up here is okay. So again, if you have any questions, make sure you ask your teachers. We're going to go over this in class, but this is a tutorial just in case you need a little extra help.